Good morning, mathematicians. Another day, another episode, another bunch of proofs. What are we going to yap about today? That's always the question. I don't know if Reddit has anything good for us today. Might. Of course, I can just yap about nonsense. It's kind of what I'm supposed to be doing. Oh, good morning, Edit Smith. Returning to being on the ball. Quality content had you beat for a while there. As the quickest on the draw. Okay. I guess we'll just jump right into it then. How did some physicists become such good mathematicians? Good morning, Deepak. YouTube doesn't even give a notification when you go live. Oh, really? If you hit even if you sign up for like notifications, I actually don't know because all of my, maybe this is bad, but everyone I follow, everyone I'm subbed to, I don't have notifications turned on for. I just watch them when I watch them, I guess. But yeah, so I don't know. That's weird. Turn on notifications, or maybe go check the settings in notifications. You just got one. Okay. So it might be something, weird on your end. Maybe check your settings. Could be that. Well, let's see this pose. I mean, I don't know some physicists do more math than mathematicians, and the other way around. These lines are so blurry. Hi, you're new to the channel. So you've only seen one or two of my videos. What are office hours for? Well, they're supposed to be a lot like just ordinary office hours that you'd have at university, so you can drop in, ask questions about random stuff. You know, what I had in mind at the beginning was maybe like people would ask me, you know, some basic questions about like analysis 1 or group theory or something. What it has turned into is usually I start off the episode by like reading some math news from Reddit, and then at some point, you know, if there aren't too many questions yet in chat, then I start yapping about pretty advanced mathematics actually, and then even when there are questions in chat, they're, you know, often about pretty advanced mathematics. But that's not a rule. It doesn't have to be that way. So I guess all of that blabbing is just to say the office hours is just a chance to hang out live, ask some questions. You might hear me, you know, yap about some like other crazy random topics. So I'm just sort of slowly scrolling up here from this is the like same drawing pad I've been using for every episode, and you can see there's just a whole mix of random topics as I scroll up. So you're somewhat in control of what happens in office hours, if you give me interesting prompts. So Newton invented calculus so he could do physics. Yeah, exactly. I mean, it's a lot easier to do something if you have a motivation to do it, right? So if you're trying to solve a physics problem and you realize that you need to invent new math to solve it, well, then you're going to figure out how to invent that new math. Makes a lot of sense to me. Oh, come on. Well, thanks. I think it's pretty cool too. So I hope you enjoy your time in office hours. And yeah, feel free to ask whatever. So this person is a PhD math student. They read theoretical physics books in their free time, and they might use tools from differential geometry, complex analysis. Very different skill set than pure mathematics and writing proofs. Yes. I don't know. I don't know. I just don't agree. I don't agree. The spheres. We got quality edit Smith feud starting for who's quickest on the draw, who's first in chat. Love to see it. Can't blame another for your own failings. Well, it's good that you're honest. But yeah, I mean the spheres of math and physics are just so heavily intersect and in such weird ways, you know, like uh you know, there's pure mathematicians who like they're doing pure mathematics, but the motivations for their pure mathematics come like strictly from physics. And yeah, there's like physicists who are doing like crazier math than I am as their like daily job. It's just, I don't know. It's a weird. It is true that there is like a primary difference in skill sets. Like I did take a particle physics course in my fourth year of undergrad that I was not prepared for, but I begged the prof to let me in because the university said I took too many math classes. Not that I didn't fill my other credits I had. They said I took too many math classes. So I was like, fine, I'll take physics. But yeah, and it is a different way of thinking. Definitely true. There's like extra tricks you can do or something that are like they're still like mathematically valid, but somehow it's very like physically motivated. It's hard to describe. But there are a few physicists out there that have either switched to math or whose work heavily uses very advanced mathematics, and they're very successful. Ed Witten is the obvious example. There's also Martin Harrier. I don't know. The name rings a bell. I don't know if I know who that is. Who got his PhD in physics, but is a Fields medalist. Oh, okay. I should know that name then. And a leader in SPDEs. There are other less extreme examples, you know. On the one hand, it's discouraging to read stories like that when you spent all your years studying math and still aren't good. Well, welcome. Yeah, welcome to the club. Well, welcome to the game. I think this is true in I've been thinking about this a lot lately. There's like more and more things that I'm learning about that follow the same pattern or at least are trending towards this state, whether that be chess, classical guitar, mathematics, or something. It's like if you want to be one of the goats, one of the greatest of all time, it seems that the stars really have to align for you. Like you need to be genetically gifted. You need to be interested in the topic to start with. Those things need to align. And your interest needs to be recognized and nurtured without being overbearing at an early age. You probably need a certain amount of stable financial support, and emotionally stable background life, and all of those things sort of like need to come together on top of then putting in a whole bunch of hard work. And if this like extremely insignificant confluence of events can occur, you might be able to be one of the best, might be able to be one of the best of your time. It's really crazy how in all of these pursuits and disciplines, probably like other academic fields. I didn't list any other academic fields, but right. And so it's like, yeah, you're gonna go to these conferences and stuff, and there's gonna be like these super geniuses, and that like that's just how it is. Like you'll never be good compared to these people. You know what I mean? There's just these crazy people out there who are insane at what they do, and you'll never be good in comparison to them. So you could be good enough to have a career, And most people, I mean, that makes you like infinitely better than like 99.99% of people on the planet. Um, so, but you know, you gotta swallow that pill at some point, and just do it because you love it, and continue to work on yourself, to work on your skills. I haven't even made it through that guy's post, but good morning, William. George asks, "What do you need for functional? Whoa, what do you need functional analysis for? You keep coming back to it, but it just seems like endless increasing specific definitions of vector spaces." Great channel, thanks. Yeah, functional analysis. I mean, of course, you're talking to a pure mathematician here. So you say endless increasing specific definitions of vector spaces. I'm like, hell yeah, that sounds sick. But I mean, functional analysis is really important, say, in quantum mechanics. I mean, we've got. I mean, I shouldn't say too much about this because I know it's important in quantum mechanics because we're working with things like, not always, but sometimes infinite dimensional Hilbert spaces, and so to make sense of that, you do need functional analysis there. I mean, functional analysis can even be like a more down to earth thing, is in some like basic like complex, in some basic complex analysis, and let's say there's like solutions to certain PDEs, and like what is it, like the Dirichlet boundary problem. So I vaguely remember this now, but this was from a complex analysis 2 course that I took in my master's. Was once you build up some of this technology of like function spaces and whatnot, and functional analysis, some of these tools could be used to solve things like PDEs, which also, I mean, more generally, functional analysis, right? It's like you maybe want to talk about some sequences of functions that converge. Maybe you can try and cook it up in a way that you have some sort of like sequence of solutions, or something, some sequence of functions that might converge to a solution of a PD, so you could somehow approximate it, something like that. Also depends, yeah. So I guess the question you're asking, what do you need functional analysis for? That's a trickier question because, well, I don't know what your goals and ambitions and needs are. I'm on the verge of spewing a bunch more abstract math, but maybe that won't be particularly motivating to you. Like all of my research and like stuff in the Langlands program. I mean, you're dealing with infinite dimensional vector spaces all the time. You need function analysis to make sense of these infinite dimensional vector spaces. Well, you can work with infinite dimensional vector spaces purely algebraically, but that's maybe less interesting, right? It's when we have the richer structure that we can get some sort of control. Hi, Jens. You're trying to understand functional analysis for non-separable spaces, and it's awful. Yeah, that sounds awful. I don't know if I've ever spent any serious time with a non-separable space, to be honest. Although you're trying to do it without learning any functional analysis. Wow. Yeah. That is, on the one hand, I would say admirable, I think it's good to really cut your teeth on something and really come up with your own way of doing it and describing it. Like, it is annoying. I've discovered things, and I was like, wow, like maybe this is an original thing, and I didn't think it would be an important theorem, but I thought I discovered some sort of formula that involved like the Fibonacci numbers mod 6 or something, and I was like really stoked. But then, of course, like someone else discovered it 100 years ago, which on the one hand is like disappointing, but then on the other hand, it's like, wow, I made a discovery that at least 100 years ago someone thought was like worth writing down and telling people about, and they named it after this guy. I don't even remember what it was now. It's some formula. I think it's named after a guy, but so it's a bittersweet thing, and yeah, I think there's a lot of value, especially if you want to be like a theory developer. There's a lot of value. Take something maybe that exists already and try and reinvent the wheel. Apparently, Grothendieck basically reinvented measure theory. That was like the first thing that he did. But I mean, this is the question for which there is no good answer. When do you know to cut it off, right? Because at the same time, you could say, well, but if you want to write proofs and contribute to the modern mathematical perspective, then, well, you should probably get caught up on what people are currently doing and the way that they currently think about things. And I have no idea how to answer that question, what the balance is. The reason behind it is there's a standard claim that the quantum field theory only ever needs separable Hilbert spaces, but I think the argument for that is not convincing. Well, I mean, I guess there's a simple way to debunk it. You just got to find a paper that uses a non-separable Hilbert space. But yeah, I mean. I think maybe when people make that claim, they're not saying that one would never. It's inconceivable that one would ever develop a math without a version of QFT without separable Hilbert spaces, but simply that it's not happened yet. It hasn't seemed to have been needed, and therefore people suspect it isn't. But yeah, I really don't know. I really don't know. How many hours a day do I work? Like actual productive work, not pretending to work. Because you've heard anything more than 8 hours of doing research is just pointless because the brain just can't. No. I mean, there's not some like magic number your brain turns off at 8 hours. Maybe there is for you, and that's your personal experience. But the problem is I have no idea how many hours I work in a day. Sometimes it's 0, sometimes it's a lot. Yeah, and the thing is, yeah, it's hard to keep track. I mean, good focused work is like, that's hard to come by. And when I feel that mode striking, I try and capitalize on it. Right now, I'm not getting a lot of work done because I have a ton of marking, and it's bearing down on my soul. The less YouTube videos I make, the more work I get done. That's definitely true. But yeah, I mean, the thing is, like, I've got like a little notebook that I'm like working on when I'm taking the train to go get groceries. Does that count? It doesn't not count. Sometimes when I'm at the gym, I'm like reading a paper on my phone or something in between sets. So that doesn't count as significantly as sitting dedicated focus at my desk in front of my laptop, but it also doesn't not count at all. So, yeah, I have no idea how to answer this question. I honestly have no idea. How many hours I'm working. I think about math a lot. It's not always the math I'm supposed to be thinking about, but, and I'm chaotically jumping between tasks too. Like last night, I was like, I writing some stuff, and I'm like, I got to mark, and then I go back and mark. I'm like, I have this idea, and then, but then I stopped to watch the new episode of The Last of Us as well. So I don't know. It's a lot of fun to develop some basic theory on your own, but it can take a lot of time. Yeah. Are there any higher level branches which you need functional analysis for heavily? In your opinion, it's easier to learn tedious math if it's a prerequisite for actually interesting maths. You're in pure math, by the way. Well, then yes, definitely. Yeah. So like I was saying, infinite dimensional vector spaces. These things just pop up like in nature, and so by nature I mean mathematics. And so you're going to need to understand those when they come up. For example, say you've got a Lie group, right? For finite groups, all their irreducible representations are finite dimensional. There's really not really much of a need to consider infinite dimensional representations of finite groups. But if now G is a Lie group, right? It's got some differential structure. You want to consider a representation of that group. Well, now it's possible that this group has infinite dimensional representations. The other thing, too, is that since this group has some differentiable structure, has some continuous structure, you're probably going to want to incorporate that somehow, right? So you're probably going to want to be talking about a topology on an infinite dimensional vector space. So, yeah. That's for me that's good enough. That's good enough motivation. But like there's all sorts of crazy stuff in like Langlands. There's a whole, you're doing like integration on groups or adelic groups or p-adic groups, and there's the trace formula. The trace formula, which relates some trace to some integral, and like figuring out. I barely know about the trace from. This is the work of my mathematical grandfather, Arthur, and his work touches a lot on the trace formula. I should really learn it better one of these days. But so this is like a very deep, important, and like difficult thing to figure out in the Langlands program, and it's like right at the heart of a bunch of like hard functional analysis on these groups. But it's like a really important tool for connecting just throughout the Langlands program. So that's motivation for me to consider infinite dimensional vector spaces and functional analysis. How do academic mathematicians get to know what's new in their field? Of course, there aren't news outlets. There aren't, but there's archive. It's never too late or early to look at archive. So I literally just every couple days, this is exactly what I do. I go to archive, and okay, you can see. Look, here's my search history in archive. Every couple days, I check out these things. Of course, the Langlands and the representation theory is for my research, and then stuff about finite groups and graphs is just things I'm looking at for fun. So I'll just put in something like representation theory. Actually, Langlands normally gives me better hits, so let me type Langlands in. So I just type in Langlands, I hit search, I see what's been published. So we talked about I opened these two articles the other day on stream, yeah, these are big. These are long, complicated articles that I think constitute some pretty big news in local Langlands. So that's huge. But yeah, I just look through this. Hey, there's my preprint. Sick. And I find papers that look like they're interesting or useful to what I'm doing. Oh, generic extension okay, modular representations. I don't work with those so much. Okay, algorithms for parabolic inductions and Jack-K modules in GLN. Okay, that looks cool. And I see published March 2nd, so I'll probably go. Actually, I have looked at that already, and I saw it precisely from scrolling through these pages. Also, there are news outlets, right? There are things. I mean, they're more pop math, but there are things like Quanta and what are the other? There's other ones I can't even think of what they're called now, but um, AMS and stuff like these like journals like AMS math, like they've got not that I follow it super closely, but they're always posting stuff or sending emails. Also things like X. A lot of a lot of academics at the initial takeover like migrated to other places, but there's still people on X and like posting about stuff. In fact, there's even some bots on X that you can follow that post papers from the archive from a variety of different topics. Uh, Academics will post their papers, So I posted my preprint there when it came out. So, um, yeah. So I mean, they're kind of our news outlets, and then there's also like if you're a big enough nerd, there's social media spaces that are very mathematical. Also, like some of the Discord servers I hang out in, right? People will post papers, whether it's their own or other papers that they think are interesting or cool or new, important, whatever. You find it's more fun creating stuff than proving solving stuff. How do you consider yourself as? Yeah. I don't know. I do kind of like it all. I do like it all. It is really frustrating, I will say, when you're. The most frustrating part for me is like the exposition, and when you're just like sitting there for an hour looking at a 5 sentence paragraph and just knowing that there's some better way to phrase it, and you spend like 5 hours changing 3 words. uh that's maybe a little bit of hyperbole, but yeah, that for me is tough. That's the tough part. But to be honest, I like it all. I mean, yeah, the creative part, the coming up with stuff is fun. I really like that, working through solving the problem. But I'm also like I'm down to just do some terrible computations and to just sit there and tech stuff up. Like especially if I'm in the right mood and like well caffeinated. Yeah, I don't mind some of that terrible work for the most part. The actual thesis writing part is I don't think it's so bad until you get to the very end and you're really trying to polish it. At the very very end, yeah, okay, then it's not so fun. But yeah, Americans don't know what marking is. Oh yeah, I think I've heard this before that some people marking, grading, uh, what else? Some other term. Marking, grading, um, psychologically damaging. I don't know. Mm. If there are no profs in your department that are specialists in your area of interest, what would be your approach? Oh, interesting. I mean, that was very much my life when I was in my undergrad, because there was one person there who was in analysis and everyone else was in combinatorics, and I was interested in like algebraic geometry and category theory and stuff like this. So yeah, I mean, you kind of gotta work with what you got, So if there's no one in your department, okay, well, I mean, this also just depends on what stage in your career you're in. So if you're in your undergrad right now, then yeah, I mean, just learn what you can from the people that are there. I mean, yeah, it's maybe unfortunate, but find a way to get interested in someone's work there, and I mean, do you still want to do like a summer research program with someone. So definitely, yeah, still try and do research. You never know. You might find that you actually enjoy some fields that you didn't think you enjoyed. B, you might try and pick the field that's closest, and maybe there's some thread connecting that to some fields that you're interested in. Um, yeah, and work your way up from there, and then yeah, when you if and when you decide to go to grad school, maybe you change fields to something you're more interested in, or yeah, maybe you end up continuing down the same path because that's the experience that you got, and you ended up liking a field more than you thought you would. Um, so that's what I would do. Yeah, I mean, you can also reach out to people at other universities, right? You can, yeah, sort of plan for the future. Cold email some people and say, hey, uh, I don't, you probably won't know a lot about someone's research, right? If you're in your undergrad, you'll probably read someone's abstract and not understand most of it, but you can cold email someone and say, hey, um, I'm interested in this area. I'd like to learn more. There's no one at my institution who's doing work in this area. Can you suggest some like reading topics for me? Maybe here's some of my background or something. I don't know. You feel like there isn't an actual sense of community online when it comes to many academic fields, and if there are, very few scholars use them. Academia is still very confined to one's own department. Uh, yeah. I mean, of course there is no replacement for the people that are physically near you in your department. Yeah, I mean that's absolutely true, but I do think there are interesting pockets of the internet. Like there's an algebraic topology server that I'm in. I don't follow it super closely because I don't do a ton of algebraic topology, but the server is like there's like very there's some quite successful mathematicians hang out there, and it's a pretty, I mean, people like joke and meme and stuff, like, of course, because it's Discord, but there's a lot of also very serious mathematical discussion going on. Um and and so I think that there are these little pockets, these little communities that do exist, and yeah, maybe not for every field, but uh, there there are these little pockets. And like, for example, my own research group, we have our own small Discord server going, so it's our local people, but then also um, people from around the world that have been, are, or will be collaborators, and so there's a lot of like fruitful discussion that happens in those servers as well. Pretty meaningful discussion, actually. So um, I think it's also partly like you have to make it, unfortunately. So sometimes you just got to do things yourself, right? And sometimes you just got to do things yourself. So if there's a lack of community, whether it be at your local institution or online for your research area, sometimes you got to be the one to step up and find a way to kickstart it. Yeah, I'm in likes computations. Yeah, low key. I'm down. I'm down to do some ugly computations. Real talk from your undergrad supervisor. Pick courses based on who's a good professor, because unfortunately not everyone is. Yeah, maybe. That is not how I did it, though. For me, I was just hungry. I didn't care if someone was a bad professor, then I just wouldn't go to class. Um, I just took courses. I just took like as much as I could. Well, pretty much strictly pure math. I wish I had dipped into statistics and applied math more. I wish I had broader horizons when I was younger. But yeah, that was not the approach I took, and I was happy with it. I think I was lucky. I think I did have a lot of good professors. I had some notably bad ones, but yeah, I think yeah, for me, it's just a matter of how many courses can I take. I wanna be exposed to like as much stuff as possible. So I never let a bad professor stop me from taking a course. You already contacted a prof and was recommended to watch the Vantage series seminars. Yeah. Um, those are quite broad. I mean, not a bad suggestion, but my recollection is that Vantage has a lot of breadth to it. So I mean that's good. Get exposed to a lot of ideas, but briefly skim through it. We'll start seriously learning it this summer. Yeah, yeah, yeah. Good plan. Good plan. Yeah, go through those videos and yeah. I mean, maybe at first, I don't know your background and your strengths, but it might be good to have Vantage seminar. Vantage seminar. Number theory is cool. Agreed. Agreed. But depending on your background, you might not understand a lot of the words and stuff. So I would say is like step one, yeah, start watching the like beginnings of videos, or even just go through the titles and see like what are the things that are coming up a lot, right? So okay, elliptic curves and curves have come up a bunch. So probably like um, a place for you to start is understanding some of this language, um, and yeah, write down words that come up a lot, right? And then realize, okay, like here, if I'm going to optimize how quickly I can learn, um, how optimize how quickly I can be comfortable with the first. Oh, you can see I was watching something about local systems from Daniel Litt. Um, so we've seen for yeah, you want to optimize to like understand the first 15 minutes of like every talk, right? So it's like, okay, I see the word super singular, an elliptic curve, hyperelliptic curve. Okay, so probably I should go like read up on that, at least have a vague understanding of the basics of those ideas, and just you know there'll be a lot of terms you don't understand, but which are the terms that are coming up the most? Yeah. It's nice having that kind of space on Discord where people can collaborate openly. In electronics, unfortunately, the general attitude is extremely secretive. Yeah, yeah. I mean, and actually, I mean, it isn't always. Yeah, it isn't always so open, and maybe also sometimes I've had realizations recently that maybe certain things should be kept more secretive. I don't really want them to. I like being collaborative and talking with people, and I like to be. I think it'd be nice to be in like a big paper with a bunch of authors and do some big project together. But yeah, also I don't know. The world moves quick, and people will, uh, you know, there's a race to try and prove things first, right? And it's not always necessarily like ill intentioned or whatever. Like, we're all out here trying to publish papers, right? So, um, yeah, I don't know. It's a delicate thing to know how much to put out there, and how much to keep under your hat. I want to put it all out there, but lately, certain things have made me feel like, I should maybe keep a little more under my hat. The fact alone that something like archive for math, physics, and computer science exists is incredible. Yeah, I mean the archive is awesome, and it also I mean it's great on so many levels. I mean the first thing is the archive, like it gets rid of priority disputes, right? Because someone might publish first, but you can go and point and it's like no, 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 my preprint came out first. But also it's very collaborative. Like there was actually some for the okay. If you go look at my preprint, there's a second version up, um, and unfortunately, I made a bit of a boo boo, and some theorems are not as strong as we had originally stated. Which is something I thought a conclusion I'd come to in a version before we published it. And then I misread something, and then I thought I had improved the theorems, but it turns out I hadn't. And then shortly after publishing, someone reached out, emailed me, pointed out this mistake. So then I went back to the drawing board with my collaborators. The second version is now, well, I just immediately put up a second version that correctly that fixes it. But also the other night I met with my co-authors and we started working on. We were like, well, hang on a second, maybe we can actually patch up a part of this argument, and we've already made progress. At least in a certain special case, we now know that we can fix one of the directions, and that's just the argument we came up with basically immediately in that meeting. Maybe we can strengthen the generality further yet, but who knows? I mean, maybe that's something for a future paper. Um, you know, any recommendations for books on representation theory? Yeah, I think I was saying last time, there's a lot of books that are good, but there's no books that strike me as like this is the perfect book. But hey, what the hell? Teams, get out of here. I hate teams. God, I hate teams. That's the one thing. If I do leave academia and go to the corporate world, I'm going to have to use Teams. I already hate that some people at university try and use Teams. It's awful. I hate it. Fulton Harris is like the classic reference. Yeah, but somehow, I mean, it's not... I don't know. It's terse. It's a little terse. It's not very terse. But yeah, what else would I say? I mean, Sayre has a book, which is also like kind of terse. If you like doing a lot of work on your own, which you should do a lot of work on your own. But yeah, I don't know. What's a book? Actually, there's a book. I haven't read it very carefully, but there is a book called A Tour of Representation Theory. My impression was, I do remember looking closely at sections of this during my master's thesis. And my impression is that this is mostly about Lie algebras, representation theory of Lie algebras, but maybe it starts with representation theory of finite groups. Yeah, I don't know. Speaking of doing things you want, maybe one day I should write the book on the book on representations of finite groups that I always wanted to read. You'll also use the book on Dessin d'enfants on Riemann surfaces by Jones Wolfert. The videos on Vantage are sequential, so you're sure you'll catch some ideas. Very cool. Very cool. Yeah, you'll have to, once you've really understood Dessin, you'll have to come and you'll have to explain it to me someday. That feeling will win capitalism. Yeah, I mean, kind of, but I don't know. I think the pressure to publish would also exist. I mean, it's not like publishing first on the things I'm working on is like there's one project I'm working on now that I want to get out kind of quickly, it's not like I'm gonna make more money or something if I get it out first. Like, I mean, maybe because there's jobs and competition, but like, it's also kind of like there are those pressures, sure, but I feel like there's pressures external to that as well. Any cool tips to approaching it? You mean reading the book? Um, no, nothing comes to mind in particular. Uh, uh, Try and prove a lot of stuff on your own. I don't know. There's another book to try and parallel. Thanks for the recommendation. You just found me recently, and you think my content is cool. Awesome, thanks. Well, I'm glad you're enjoying it. Oh, you've also got that book. Okay, I love it. I love it when there's cross that there's recommendations happening in chat between people. And the Schnepp's book. Do that once you understand a common ground. Wow, looks like you're all set up with reading materials. Yeah. Okay. Where are we here? Should we go back to like 30 minutes ago when I was reading this post? Where were we? We were right here. I can't fathom how one can jump into research level math without having worked through countless undergraduate or graduate level exercises. Yeah, but a lot of physicists have. Yeah. I mean, you're a math PhD student. I don't know, like, maybe you just don't have an accurate impression of what the typical physics PhD student is doing. I mean, they're taking advanced math courses too. On the other hand, maybe there's something a graduate student like me can learn from their transition into pure math, other than their natural talent. Yeah, well, natural talent's a big factor, but yeah, keep an open mind. Go to a lot of seminars. Go hang out in your physics department. Maybe you can make contributions in the other way. Yeah. There's an undergrad representation theory book, An Invitation to Representation Theory by Michael Howe. Oh, interesting. Let me bring that up. I might have actually cracked open this book before because I was trying to polynomial representations of the symmetric group. I see. Yeah, I think I actually cracked this book open because I was trying to learn some stuff. I actually never dove super deep into the representation theory of the symmetric group. Not as deep as I would have liked to. And there's some stuff for a little side project I was trying to digest. Yeah. So I think I was looking at this because of that. Yeah, I think I might have jumped over to this to young symmetrizers, and there's things I was trying to understand there. Which I do wish I had understood this better. In particular, like the Spey modules, these come up in the representation theory of GLN, and there's some like cool stuff going on with like Hecke algebras and like duality theorems, giving you some sort of duality between representations of the symmetric group and GLN. So maybe this is a good book. I don't know, Nerdy Quagsire, if you're still here. Well, is this a good book, though? Because how much is it... how much does it talk about the general theory of representations? Yeah, I don't know. But then again, maybe it's good to just really sink into the rich theory of symmetric groups. I don't know. Yeah. Still somewhere in the back of my mind, I'm like, I should I should write a representation theory book. I am underqualified to take on such a thing. There's so much even about basic representation theory. I feel like I don't know, but also what I would write would probably be just like filled with categorical nonsense, because I like putting in a bunch of categorical nonsense. Um, but I guess there's a lot of other people that like categorical nonsense as well. So I think that might do it for today. I think that might be the end of the stream. So thanks everyone for joining me as usual. I hope you're all inspired to go prove some theorems. Does rep theory have any analysis like Lie theory? Got disappointed. Yes, it absolutely does. I mean, not so much if you do representation theory categories of the real brain rot. Well, then consider my brain rotted. Yeah, but I mean, so definitely if you do representation theory of finite groups, no. If you do representation theory of Lie algebras, I feel like all the stuff that you don't need analysis for has been worked out. So, I mean, there's the representation theory I do has like minimal amounts of analysis, and the analysis uses the p-adic numbers, which is a lot nicer than the analysis of the real numbers in many ways. Anywho, that'll do it for today. Go prove some theorems.